space is going through a real revolution. The activities we carry out on Earth depend on what happens beyond the atmosphere. And the role that companies play in this sector is growing. It is the new space economy, with private companies collaborating with public institutions to boost research and innovation in orbit. And this is a beginning in Italy, but it is a reality in the US. And today we will witness it with one of the first space crews from a major American company, AXIOM, which is revolutionizing the sector, building the first private commercial space station. But before we welcome the crew of the AXIOM-3 mission, I leave the floor to Antonio Carcaterra and Giovanni Battista Palmerini for an introduction, please.
Good morning, everybody. So, welcome to the crew and welcome to the Italian Air Force, just on behalf of our rector. So it is a special occasion for us, and I would like just to thank you for inspiring people, because of course in this occasion we have just technology together with people and together with person, and we think actually that is a very motivating element in our young people, our young students, for the new generation and for us. So thank you for inspiring these people that is here today. Thank you.
Thank you, Professor Carcaterra. Professor Palmerini, please.
It's my time to say a warm welcome to all the crew.
Nearer to microphone.
Sure, thanks. So it's my time to say a warm welcome to the crew. Actually, from School of Sapienza, the School of Aerospace Engineering, which was one of the oldest institutions of the world, we especially welcome Colonel Villadei because it was associated with us in his studies. But as Professor Carcaterra did, I really thank you for inspiring our people, our young people, which is the real motivation for us to work and for Sapienza to exist since 7 centuries. Thanks a lot, and thank you again.
Thank you, Professor. Thank you, professors, for your hospitality in Teatro Ateneo. The Air Force played an important and far-sighted role in establishing a partnership with AXIOM. General Francesco Vestito, Director of Military Personnel Employment of the Air Force, tell us about it, please.
Thank you, professors, faculty, principal, students. I bring the regards of the Air Chief of Staff, General Luca Goretti. I'm myself a pilot, a tornado pilot, so I need air to make my engines breathe and work. I bring the presence of the Air Force. We live just across the corner from the university. Thank you, astronauts, for participating in this event. Space is very important for us. We do work in the air domain. We need space, this global common, to make our air operations work. In the space, we have communications. We send pictures, communication, space weather, all the stuff that needs for 5th generation. We are working on the 6th. And we need to work the 4, the 3, all the system connected to it. And that's why space is important for the Air Force and for humanity. At the same time, space means space economy. It's very important for Italy to have its role in the space economy, and with this, its technology and so on. So Air Force is participating with AXIOM in this great alliance to bring experiment in the space. We are doing experiments on human resources so that we understand more about gravity, medicine, pathology, and how the human body reacts to zero gravity. And so the last message is Air Force is a catalyzer of this participation to space in non-space activities, in space activities, and mainly academia and research. We are there for you guys. Please, students, invest all the time you have now. Time is a very precious resource because the future could be very enthusiastic for what you are doing and for your nation and humanity. Thanks a lot.
Thank you, General. Now it's time to experience the excitement of space travel. Let's watch together the video of the AXIOM-3 mission. Chiedo alla regia di mandare il video. Grazie.
For some reason, every time I think about the countdown, it starts at T minus 7 seconds. I don't know why. 7, 6, 5, 4, 3, 2, 1.
Okay, JK, everybody, this is a Spaceship Freedom. Here we are above the Earth. Amazing ride uphill. We're very proud to be representing Axiom and our nations here. I couldn't be happier to be here and prouder of my guys. It's just a great job all the way uphill.
On behalf of the Expedition 70 crew, I'd like to welcome AXIOM-3 on board the International Space Station.
Welcome aboard AXIOM-3 station. We are now resuming operational audio communications.
I am very proud of my AX3 crewmates who helped their agencies achieve all of their science objectives, technology demonstrations, as well as the outreach events.
So what I really hope this experience as a family will bring to them, it's the self-confidence that nothing is really impossible. I want to be an example, and I want to be part of those that make something impossible possible.
This is not a mission of a single individual. This is not magnifying a name. This is just the ignition moment. This is not the end. This is just the beginning.
Here we are the protagonists. Let's meet them, please. Come on the stage. Michael Lopez Alegria, commander of the AXIOM-3 mission, former NASA astronaut. Michael is the business development director of Axiom and was also the commander of the company's first mission. Welcome. Walter. I introduce you all. Walter Villadei, Air Force colonel and pilot of the AXIOM-3 mission. For Walter, the one to the ISS was the second time into space, as the year before, he flew on the Virgin Galactic suborbital flight. Welcome.
Buongiorno.
Alper Gezerauce, mission specialist and the first astronaut of the Turkish Air Force, which is pilot and engineer. Welcome. Marcus Band, mission specialist, Swedish Air Force pilot and the reserve astronaut of the European Space Agency. Welcome. As you can see, a diverse and international crew, and this is certainly a characteristic of space missions. Departing on 18 January aboard the Crew Dragon vehicle provided by SpaceX, in the space spent aboard the International Space Station, each of the crew members carry out a series of microgravity experiments by space agencies and industry of their own countries. I would start with the mission commander, Michael Lopez Alegria. What were the main challenges in planning and conducting AXIOM-3, and what lesson did you learn from this mission? Please.
Yes, thank you, Flavia, for the question. And first of all, I want to say how pleased I am to be here, to be with you. It's an important aspect of what we do to try to inspire the next generation to pursue careers in aviation and space. We're all aviators, and we are very pleased to have your interest and your attention, so thank you for coming. I would say probably the most challenging aspect of the planning was trying to fit everything we had into 2 weeks on board the space station. As you heard, the crew does a lot of science experiments divided between the 3 crew members, and we have some limitations on the space, on the facilities that are being used on the ISS. Of course, we're joining a crew of 7 people who are already on board. So all of us 11 people have to work on the same facilities that were designed to be only used by 7. So we have to plan things very carefully to make sure we're not overlapping with time. And the time is really the biggest resource. So we on a normal day, first of all, I should say we use UTC, Greenwich Mean Time, as our clock, because as we're going around the Earth every 90 minutes, we can't very well use the sunrise or the sunset like we do here on Earth. So we wake up at around 6 a.m. and we start working at about 7:30 usually. This is a conference that we have first with Houston and then with 4 other centers around the world to sort of plan our day. And then as soon as that's over, we start working, and we work until about 6 p.m. or so at night with an hour break for lunch. And what that means is that we have, like any job, we have a very limited time to accomplish our experiment. So it's really a choreography between the payload, the science representatives, and the people who are familiar with the space station to know how to manage to get all of those experiments timelined in the certain facilities by each crew member at a time. And then the second question, I think, was about the lessons learned. And what I really want to emphasize is that this mission went remarkably smoothly. And I think it's a testament to how well trained and how prepared the crew members were. I also flew on AX-1, the first mission, and we learned a lot about what items should be emphasized during the training and what items perhaps we didn't need to spend so much time on. And we improved that on the second mission, AX-2, and now on the third mission, I think we are pretty close to achieving the exact mix of technical training, practical training, and maybe not focusing so much on some of the more nuanced items that we might have to do someday, and focusing more on the things that we know we'll have to do every single day. And for us, really, our lives are run by some tools. Basically, they're laptop or tablet-based programs that tell us what we should be doing at a given time, where to find a procedure to do that, where to find the tools that we may need to do to execute the procedure. So practicing with all those things, which is not something, it's not a Microsoft Office, it's a little bit more complicated. So we spent a lot of time doing that, and I think the results show that we did it well.
Thank you. Walter, tell us about your stay on the International Space Station.
Grazie Flavia. First of all, let me thank you, these students. I'm very glad to see students from the university, from the School of Aerospace Engineer that by chance was funded by, established by the Air Force, Gaetano Arturo Rocco in the 30th, just to face. That was back at the time a new era. It was an aeronautical era. Now we are facing the space era. So it's like a kind of return of the history. So we are really paving the way for a great opportunity for these students. So how was the life on the ISS? As you've seen, maybe the quality of the video was not the best, but anyway, you saw that since the very first moment until the very end, the first mission is like any first experience. It's something amazing that you can't forget. Is really very, very valuable. As soon as you go into the ISS, you found completely different environment. You have to learn how to adapt yourself. You are still beginning to adapt yourself during the launch, and then we've been for 37 hours before docking to the ISS. But then once you open the hatch, you stay in such big volume, and you have to appreciate the beauty of floating, but then even learn how to handle with your body. And then at a certain point, you start working, as our commander was saying. We had, all of us, a quite tight schedule to follow. But then you realize that you are doing something which is a part of something much bigger, because we have scientists on the ground. You have people talking to you every moment you need. So you really feel this kind of being part of a team, and you do your experiments. And then, of course, the beauty and the beautiful experience, the unique experience that you can have once you go to the cupola and you look below, and you look the Earth passing 28,000 kilometers per hour is a beautiful view, something that can stuck in your mind. I was saying a few days ago, we should send poets in space, not only engineers and scientists or pilots, because it's very difficult to really by words just simply tell you how beautiful was this experience to see all these pale blue dot underneath us. So the experience was remarkable since many angles. The most important, of course, once you are a part of a mission, you realize that in the end the mission doesn't really start with when the countdown hits 0, but it starts way all before the mission, because we have been interacting with the scientists, with the Air Force, with the Italian Space Agency, with the industries to prepare the pilots. And then after we splash down, we have such long period of time when we are engaged in talking to people. So it's kind of an extended mission, but this is the added value that we can bring and share with all these students and communities.
Thank you, Walter. Alper. Alper, being your country's first astronaut must surely be a great honor. How do you think your experience on AXIOM-3 can help inspire Turkey as well as other countries that are starting to invest in space?
Thanks so much for your question. First of all, dear friends of the students and the faculty, I really want to thank you deeply for your time and energy to come over here and attend our session to share our stories. There are some moments in human's life which is taking a short time but putting a big impact in human life. So I believe that in some of your lives, this moment is going to put a big remarkable beginning of your future stories, and hopefully in quite a positive way. Coming back to your story, to the question, Turkey, as being out of European Union, European Space Agency, as well as the human cooperation on space, that was a really remarkable moment for my country initially to give a huge inspiration for our youth generation. Achievements in sky and further in the space is fostering a sense of national pride. That's what happened in my country. Our youth generation have been hampered all the time in their self-confidence in quite negative ways most of the times, for just encouraging them in a negative way and discouraging them with the things that they can't really succeed in. This huge accomplishment, as I have been joining several conferences, and to name it, in the last 6 months, more than 97 cities and more than 140 conferences so far, I see the clear reflection in their eyes, how positively it affected their self-confidence and gave them inspiration for their future goals. Not only a single country, as you know, Turkey is placed in such a geopolitical location of the world, bringing together 3 different continents. Not only physically, but also cultural-wise, it's impacting on a lot of countries in Africa, in Asia, as well as northern part of the Russian territory. There are a lot of people getting affected from these accomplishments in quite such a positive way, like even as a citizen of a country which is totally out of the game, you can accomplish things in different evolving parts of the technology and different parts of the humanity, including this space. Also, it's giving a public, it's boosting up the public awareness. What can really be done in terms of new capacities in different parts of the technologic innovation. Also, the attention of the governments, they are focusing more now into investing potential areas that the country can take part in for the future time. So it has a huge positive impact in several different fields. Thank you.
Thank you, Alper. Marcus, being also an astronaut in the ESA reserve, how do you see the future of the international cooperation in commercial space missions? Do you think missions like AXIOM can further strengthen these ties? Please.
Yes, yeah, definitely. First of all, thanks for the question, and it's great being here and seeing what you're building out here as well. I just want to join you and build those things with you and send them to space. It's awesome. It's very inspiring, and you are the future, just as the general said here. Yeah, absolutely. So I entered the selection for ESA, for the astronaut selection for ESA 2021. Got through and found myself in the class to my big surprise. And that's something that I should mention because that felt very, very unlikely. And something I want to send to you is make a very clear difference between impossible and unlikely. Those are 2 different things. Don't forget that. Also, impossible and hard. If it's hard, just work harder and you'll make it. Just keep that vision, just keep focus on the vision and power through. When it comes to the international collaboration and the possibilities to get to space, so Europe has a limited access to space, have had a limited access to space, and that also sets how many astronauts we could be calculation-wise in Europe. By the capabilities that companies like AXIOM delivers or makes possible and accessible, the frequency to getting up to space for Europe changes a lot. So during this selection, the reserve concept was installed at ESA, and I don't know how many believe this would happen or not, but anyway, it was installed, and apparently it works due to companies like AXIOM. So by having AXIOM making it possible to get access to through space in a, let's call it, non-traditional way, ESA also was bold enough, and that's that's actually a little bit credit to ESA that we had the courage to do it in a way we didn't do it yesterday. So Sweden, together with ESA, joined up with AXIOM and got another astronaut into space. And when it comes to the international collaboration, this has been a fantastic journey with 4, 5 different countries involved, and it's that combination of countries would not have happened without AXIOM, because all these countries came wanted to go to space, wanted to push the boundaries, wanted to learn more, wanted to be a part of the future space economy and development innovation by themselves, but then ended up in a crew together, which also makes, now we're here, right? So now we're traveling to all the countries, interfacing with new people, new capabilities, and find a lot of connections. So I think that definitely drives development in a very good way.
Thank you, Marcus. I come back to Michael. How has your experience changed from NASA to AXIOM?
Well, I would say in some ways it's very similar, and in some ways it's very different. So a mission, I flew 3 space shuttle missions and 1 long-duration mission on the ISS while I was at NASA. And really, all of those missions have in common with the AXIOM missions is that we're doing research. We're using the unique environment of microgravity to be able to study things that we can't do on Earth because the force is so strong, so preponderant. And so in some ways, the conduct of the mission, the profile of the mission, sort of the view of the mission from far away, it's scientific experimentation, technology demonstrations, and then events where we communicate to the public. So that way it's very similar. It's very different because when I was an NASA astronaut, I was really worried about my own plan, my own experiments, my own requirements, things that I had to do that I felt like I was contributing to the team. As a leader of this team, I'm much more focused on their accomplishments of their requirements, so their experiments, their demonstrations, their outreach events. And so in some ways it's a little less pressure, and in some ways a little bit more pressure. But it's such a pleasure to work with these 3 fine professionals. I really enjoyed it.
Thank you, Michael. Walter, talk about the experiments. During the AXIOM-3 mission, you had the opportunity to participate in scientific experiments on board the ISS. What impact and repercussion do these experiments have on everyday life on Earth?
Well, that's a good question. I guess this is one of the main points. We go to space, all of us, countries, nations, organizations, because we want to try to push the technology and the scientific research. So we went through multiple experiments, but I mean, just we want to leave some time to the students to make their questions. I will just pick a couple of them. And scientifically wise, thanks to the collaboration with the Italian Space Agency, I had some experiments dealing with the aggregation of those proteins which are considered the cause of the Alzheimer or the Parkinson's disease, so the amyloid proteins. And actually the astronauts is a kind of an operator. We have to follow some procedure and to do some stuff to make then the data available to the ground. So that was very important, and you can imagine which kind of impact this can have on the future of the humanity on Earth. A couple of other important experiments to us were, for instance, the development of a new fly suit with new fabrics, and then trying to integrate the sensors in order, with these wearables, to monitor the health of the astronauts during the activities. And even this kind of technologies can have an impact on the ground, since you can monitor a much wider range of people in the different sectors. And then let me just mention quickly one important experiment we did as Air Force, because as you know, I'm sure, as a students in engineering and space nuts, you know that space is full of junk and full of debris. So we developed internally as Air Force a software just to build up a capability to make an assessment in terms of risks. And the nice thing is that we were able to, thanks to the cooperation with AXIOM, make the ISS connected to the Air Force server, which is not absolutely easy, not impossible, but very unlikely, but we did it. And so I could have the opportunity to run a few times this software, testing it from space. So again, and just closing for these important questions, I guess this is the key point. All of us are instruments for our respective nations to fulfill and carry out experiments.
Thank you, Walter. Alper, I come back to you. Working in microgravity environment presents special challenges. What were the most unexpected things of daily life on board the ISS, and how did you adapt to these new conditions?
Microgravity is a great opportunity for you to get over the difficulties, especially in science, that you are facing here on Earth. However, as with the nature of the microgravity, it's bringing up new challenges to deal with up in space. For example, the items from food to the utensils that you need to execute your experiences are floating away. Any moment you turn your head away from the item. So for any single item, you need to just use Velcro or other straps to tether them to somewhere in order to keep them stable, in order to find where you hope them to be. And other things, the habits, when you are consuming food, water, and other things, in order to maintain your physical capabilities, are different than what you are used to here on Earth, as well as getting rid of the excess items out of the body. That is also quite different than what you are used to here on Earth with the help of the gravity. So we are going through really in-depth training through the preparation process, and on top of that, experience is a great treasure. So our predecessors, like our commanders, who have accumulated a huge amount of experience ahead of us, has given us a great chance to be able to have all the things in our minds to be ready for the reaction that we need to take. So, and plus, he took us under his wings and gave us the consultation that we need 24/7 during the flow of the mission as well.
Thank you, Alper. Marcus, space missions require strong teamwork. How was your experience working with other AXIOM-3 crew members from different backgrounds and cultures?
Yeah, that's an important statement. It's super important that you do a good teamwork, and I think that's something that's one common denominator for astronauts in general. Good team players, that's very important, and that's of course not only important for astronauts; it's important for everyone. It's very interesting to be together with different culture, different persons, especially when you have to do something where you need to trust each other with your life, and that's something that I find very interesting. I think that's key, and that goes for everyone in this group, that we are, I would argue, generally interested in the other person. So I think that's something important. And when you are that, and when you have a question, you should ask that question. That's something I want to send to you as well. Don't be afraid. Of course, be polite and respectful. But if you're from different cultures, or even if you're not, and you think something is weird that's being done in the group, you can just ask, like, why are you thinking like this? I think like that. And maybe there's no right and wrong, just different ways of doing it. And if you do that fairly quickly, the group will be tight, fast. And then you can start to trust each other and be very efficient. We are also all military aviators, so we had some things that we were used to from the start. So when it comes to following procedures and how to chain of command and all that, so that kicked us far down the merging process as a group, but then we can work from there. So it was an amazing team to fly to space with them.
Amazing, thank you. Thank you very much. Now is the time to the Q&A session. We can start with your question. I would ask you to indicate your name, please.
Hello, I'm Daniel Ortega. I'm an officer of the Chilean Air Force, currently studying here in the a master of aerospace engineer. I'm pretty nervous right now. My question is, me as an officer, as an aeronautical engineer, and as a Chilean person, how can I reach that experience you reach of being in space? That's my question.
Thank you. Sorry. Who wants to answer? Walter. No.
So, first of all, you are on the right path. I mean, you are studying aerospace engineering. You are in the Air Force, so you are on the right spot. How can you reach this kind of achievement? Well, if I correctly understood your question, I guess you might be, because I don't know how many astronauts you did in your country, maybe none. You can build up your own path, putting together the opportunities and the experiences you are gathering. So you are in a country, and I follow a path very similar to yours. So inside the Air Force, you can build up, but the main point is try to use your experience to build up a culture inside the organization and inside your country. So it's like to make more valuable what you're doing as a person now in the view of achieving your goals, but at the same time try to build up a kind of unity of intents with other people, so you can be instrumental for getting to space with your own country.
Thank you, Walter. Thank you for your question. The second question, please.
First of all, good afternoon.
Please,
Good
your
afternoon.
name.
My name is Sahiti. As an onboard system engineer, I want to solve your problems in space. So could you tell us your real struggling areas in space?
Okay.
I don't think we understand very well the question, but could you repeat it or say it a different way,
Yeah.
please?
As an onboard system engineer, I want to solve your problems with smart devices. So could you please explain your real struggling areas in space?
Thank you. Thank you for your question.
You want to find a solution for potential problems that we already had over there, and you want us to point out that potential problem areas for you to be able to find solution with the technology, right? Did I understand correctly?
Yeah, I just want to know your real struggling areas. I want to solve that problems and make devices.
Okay, I'll point out a very clear answer to that. Hygiene is a problem in the ISS, as you cannot find the resources to the conventional or the traditional cleaning habits that you maintain here on Earth. So a closed cabin with a floating water, if you can do, with the technology that you have in your mind, would be a great solution. Or at least for a system that you can just put your hands in and have a floating water over there would be a solution. So that's one of the main qualities that's affecting the daily life over there.
Please, the next question, maybe here. Okay. We have time for 2 questions more. I'm sorry, we are late. Please. Please, your name.
Yeah, thank you very much. My name is Tong Tong from China. And thank you very much, firstly, for your sharing. And my question is, do you think is it possible for astronautics or robotics to work in space and to build a larger spacecraft by modular assembling technology? Thank you.
Marcus, please.
Yes, so your question, if I understood correctly, is if it's possible for robotics and to work and do modular assembly. Yeah, that's exactly what we're doing, I would say. We have robotics and they are both manual and autonomous. And generally, when it comes to autonomy and robotics, I think there is still a lot we can do, that we can build more robotics with more autonomy. And I think some of the space stations being built right now are not built to be crewed all the time, so they will be autonomous in certain ways, and some things will be controlled from Earth as well. What I think is important is to use that automation in a way so we collaborate together with the automation and still go there as human beings to explore, to find the things we didn't know we were looking for. Because a lot of times when we program something for autonomy, we have a set mission with that and we program for it, so sometimes it becomes really, really good at that task, but might not have that human perception of what we're seeing out there. So I think there's definitely a space for, or room for more robotics and autonomy in space exploration, and we should do that together, human-machine teaming. Thank you.
Thank you for your question. We have time just for another question. I don't know. You have to choose. Please, your name.
Hi, I'm Gianmarco, and my question is mostly directed to Michael, but also I have a question for all of you, which is, what is the biggest personal challenge you faced to get to where you are today? And then to Michael, how has the space industry changed from when you were on the space shuttle missions to today? And what do you see for the future? Thank you.
Thank you, Gianmarco, for the question. It's changed a lot. When I started my NASA career was 1992. Then the space station was someone's imagination. I think we were starting to think about it, but it didn't look at all like it does today. And so there has been an evolution within the government space programs from very national focus to a cooperative one with now 5 agencies participating as partners in the International Space Station. But now we're taking yet another step, and that is this advent of private commercial spaceflight. So when I flew my last NASA mission was 2006, and we were only then starting to fly commercial spaceflight participants one at a time on the 3rd seat of the Soyuz. And the mission that we flew in 2022 with AXIOM-1 was the first all-private mission to go to the ISS. So for 6 decades, pretty much only governments were able to go to space. And in the beginning of the 21st century, companies started having the ability to be able to create not only satellites, but launchers to get people and cargo to space. And that has really changed the way that we think about going to space now. So whereas before it was a very artisanal challenge with very specific labor force to be able to produce a rocket, let's say, now you see SpaceX is doing it, and this is all as a result of advances in information technology, 3D CAD design, 3D printing, computer-aided manufacturing, etc. And so now this reusability, this producibility increase has really changed things. And so I think now it's not really a competition between commercial and government, but the government now goes on to do things in deeper space, to the moon, maybe one day to Mars. And commercial companies are able to exploit this microgravity environment in low Earth orbit and create an economy there. So that's what I see for the future.
Thank you. Thank you, students, for your question. Thank you to the crew of